What's that first thing that you're looking for, that physical or behavioral sign that kind of tells you whether this is a solid shop or there's something a little amiss?
It's dirty work, but cleanliness is a big thing. I mean, you know, and maybe not being, I'm not saying that you can't have a pile of grit in the corner or something like that. But I mean, orderly, um, clean, tidy, organized, those kinds of things come across very quickly. I think the body language of shop personnel is, as I was saying, is
It's
another
huge.
clear indication.
Welcome back to Forged in Focus, the podcast where we dive deep into the issues shaping the future of American manufacturing. I'm your host, John Ward. Most equipment failures don't start in the field, they start in the shop, during fabrication, long before a plant ever sees the vessel, heat exchanger, or piping go into service. Today's guest has spent decades inside chemical plants and fabrication shops figuring out where things actually go wrong. Not in theory, not in standards, but in real life. We're joined by Ed Naylor, a reliability and mechanical integrity specialist, a bona fide subject matter expert with deep experience across owner-operators, industry groups, and consulting. In this episode, we're getting into when to inspect during fabrication, how small misses turn into big failures, and what separates a shop that truly has quality under control from one that just passes audits. If you've ever asked yourself, are we inspecting the right things at the right time? Then this one's for you. Well, Ed, welcome. I'm
Thank
so
you.
excited to have you on the podcast today.
Appreciate it. It's looking forward to it.
Oh, yeah.
Novel idea and kind of a new concept. So
Oh, yeah.
getting used to it.
I was sitting there thinking about as I was preparing for this, I've known you since the day I came in the industry. I mean, I've known
Really?
you for decades. So,
Yeah.
I've always enjoyed our friendship and working relationship. And so really excited to have you here today.
Thanks.
All right. Before we get into the meat of this, we got to clear one thing up.
Oh,
There's a lot of debate about the proper color of red, and I just want to make sure that you and all the listeners understand that PMS, the Pantone Matching System color code 201C for crimson, as in Roll Tide, is the primary color of red.
I see. I would disagree. I would call scarlet the proper color of red.
All right. I guess we will leave it at that, right?
And
I'll just
Ohio
give you
State, Big Ten, SEC. I mean, now that I've relocated down to Tennessee, I've got an awful lot. Tennessee has an Alabama license plate, for heaven's sakes. And so there's plenty of Alabama support, but I will say there's an awful lot of Big Ten in the greater Nashville as well.
There you go. Awesome.
Yeah.
Well, Roll Tide. That's all.
All right, we'll see. The University of Alabama Elephants. Go ahead.
Oh, man. Well, listen, you've been in materials corrosion and reliability for more than 35 years. How do you describe what you do to someone outside the industry?
Oh, that's always fun. I start by just saying I'm in engineering. And if that's enough, that's great. Otherwise, if they make the kiss of death follow-up question and say, "Oh, really? What kind?" Now got to be very perceptive and watch for the eye roll or the look around the room. I got to get out of here kind of moment with them. And I basically explain mechanical integrity, equipment reliability, inspection of new and used equipment for the chemicals industry. And like I said, then they turn and say, "Oh, Jack, long time no see." And they run.
I have the same problem. I have a hard time explaining what we do to people in less than 3 to 4 sentences.
Yeah.
And after 4 sentences, there's a glimmer. And then when I say, okay, all the products that we make revolve around everything you buy on the shelf at Home Depot, hair products at the stores, and then the light bulb comes on a little bit as to what runs through our type of equipment. So, So take us back to the beginning. You talked about engineering, chemical engineering at Cornell, metallurgy at Ohio State. What pulled you towards materials, corrosion, and mechanical integrity instead of that more conventional process engineering route?
Yeah, it was kind of a karma. Everybody in my family was a chemical engineer. My brother, my brother-in-law, my father, my brother-in-law's father. My grandfather was an applied chemist only because chemical engineering didn't exist, is my suspicion. So I was pretty confident that I wanted to go into engineering just by how I thought, who I was, what subjects I was good at. But I kind of felt like I knew enough about chemical engineering. Um, so my father was in a fraternity, and he had a bunch of industry friends who were in, well, electrical engineer, and one of them was a materials engineer. And I went around and visited with them and toured their facilities and things like that. And my predecessor at way back in AXO was one of those gentlemen, and he kind of walked me through his diary. Um, a whole bunch, always a new, a day full of seven different questions or issues or something like that. And so I took a summer job after junior year with him and was fascinated by it. So, I mean, really, that's the genesis of it. And I just kind of thought maybe this is going to be more fun than sizing heat exchangers and reading pump curves for the next
Yeah.
40 years.
Oh,
So,
yeah. I mean, you get involved in everything, which is the
yeah,
beauty of it. And I love how we're all impressionable at a young age and tend to kind of follow a lot of times in our father's footsteps. I did the same
yep,
thing, which
yeah,
is great.
yeah.
Well, I know you've spent decades with Nurion, Axo Nobel, and I know you're with Beck now and deeply involved with MTI. How has your
Sure.
perspective shifted from going from an owner operator to more of a consultant and industry body?
Yeah, it's definitely different. It's a bit liberating to be out of the corporate environment for one. But the questions that come up and things like that. I mean, you spend a lot of time in one company. You know each of the plants. You know what their chemistries are. You know what their general challenges are. When you get into either the MTI forum or a consulting role, such as with Beck, you have no idea what the next question is going to be, or where it's coming from, or what industry it's going to be, or anything like that. So that's I think been the biggest change, and it's an exciting one.
Yeah. Yeah, I'm sure every day is a brand new day for you. Different challenges, different
It
things that are
is, and
put
that's
on
what I
your
liked
plate.
about it in the
Yeah.
first part. In the beginning, like I said, it was the whole materials field. I mean, okay, it's a specialized field. But within that specialized field, I've been very much a generalist. I mean, I had to know about metals, alloys, gaskets, coatings, linings, paint, welding, inspection, NDT.
Yeah.
It's like
Oh, yeah. It's
they're
all.
specialists for all these things, and everybody just kept coming to me. And that's some of the value of MTI is, and being in a place like Beck. I mean, I was on a project not long ago, and some issue about piping came up or and welding, and you know 2 years ago I would have been the one answering that question, and now
Right.
it's like I don't want to step on toes here. We got a
Yeah.
welding guy, we got a piping guy, we got all these. So
A lot of resources.
yep.
And I know, all those years, I mean, you've branded and are known as a corrosion and materials SME, a subject matter expert. What's one of the corrosion mechanisms that still surprises people in how fast it can bite them? Is there one thing that you saw over and over again during your years?
Over and over again, but it's not the same mechanism, and that's localized corrosion. I mean, any kind of, and it can come in a lot of different forms. Um, it can stress corrosion cracking can happen very suddenly. Um, fatigue happens. You might have a fatigue issue that you don't know about until it fails. Corrosion under insulation, under deposit attack is an excellent one where you just get some sediment or some grime, and all of a sudden you're not looking at it, and all of a sudden it's a hole or it's an issue, and it's a leak. So I would definitely say that the various forms of, and they're some of them are hard to find, some are hard to look for. those are still the ones I think that take people by surprise.
Now, a lot of that is it material selection issues? Because I know a lot of folks
Sometimes.
really love the carbon steel, stainless steel for the
Right.
price standpoint.
Right.
And is it a common mistake that they're making with material selection for various services?
I mean, it can be. There's different approaches to that, and 20 mils a year corrosion. Take it as a number. That can be tolerable on carbon steel, and you might even say, okay, I'm gonna do the math, and I'm gonna add an eighth of an inch, or I'm gonna go schedule 160 or something like that. You can. It's cheap corrosion allowance. 20 mils a year on Hastelloy C276, big different ball game, or 20 mils a year on zirconium or titanium, forget it, unheard of. So that comes into it. I think another thing is processes are constantly being improved, tweaked. Um, we want to, I know in my old company, we had a lot of issues around making surfactants biodegradable was a big push. Okay. Because the customer making the detergent needed it to be biodegradable. So we had to modify the surfactant to be biodegradable because a lot of them weren't. They were just more effective as non-biodegradable. Because I mean, the volatile organic issue been going on for years. Those were great coatings, but they weren't the way of the future. So we had to make some modifications. You do that, and you want to use the same equipment, and you're not doing a review of it, you could get yourself into problems there with, you know, I don't know, passive material selection. You're
Right.
you're selecting materials by not selecting materials. You're just changing the process.
So how do you balance that from selecting from the gold-plated materials, let's say the exotic alloys, versus living with a certain amount of degradation and managing it through inspection and risk-based approaches?
That's one of the biggest challenges, really, because I know in my experience, nobody really wants to talk life cycle costing. It's a valid, it's a very valid methodology, uh, but if it doesn't fit to depreciation, or it doesn't fit with the current, oh, we don't want to spend $1 million on this project. We only want to spend 400,000. Everything starts to get trimmed down. So I think that's been the hardest. You can make the argument, say, hey, you'll get, or you'll never have to look at it again. You make it out of titanium, you'll never look at it again. But you can make it out of a nickel-based alloy, and it'll give you probably 25, 30 years.
Yeah.
So it's kind of design life, and it's
Now,
working
is it
within your limits. I mean,
is there a certain life expectancy that folks are trying to target?
that varies too. Everybody says 20, 25 years, but then they want it to last forever.
Right.
So,
Right. They want to pay for the 20 to 25 years, but they want it to
right.
last forever. Gotcha.
Exactly.
Yeah.
Exactly.
Okay, that makes a lot of sense.
Yep.
Well, listen, I know you hold a lot of certifications with API that cover pressure vessels, piping, tanks, source inspection. Where do plants most often underutilize those standards or misinterpret them?
I think they're doing a good job of utilizing them. I think they're doing a bad job, with regard to interpretation. And the my experience has been walk into a facility and say, let me see your PSM program. Let me take a deep dive into your mechanical integrity program. Oh, how do you inspect? How do you address pressure vessel integrity? Oh, we inspect the API 510. Okay, but all they really do, they say they are compliant with API 510, but there's a lot in API 510 that people don't know about or don't pay attention to. It isn't just call up the inspection company and say, I need a 510 inspector, come out here, complete the form, do the inspection, and we're done. There's a whole lot more to it with regard to follow up, making the calculations, doing inspection intervals and corrosion rates, and modifying the inspection test plan. I mean, that's mainly why I was in a central engineering function. I got my certifications less to actually physically do the inspections than I did to write, create, and modify inspection test plans, and I did a lot of code interpretations. People would say, "Well, what do we really have
Yeah.
to
What
do
does this
here?"
mean? All right.
Right. And then I would be able to say, Ed Naylor API 1, 2, 3, 4, 5
All right.
to give a little bit more validity to that statement or that opinion.
Yeah. And we found that over the years, it's been a little bit more of a challenge is the training isn't there like it was 20, 30 years ago. We're
Mm,
bumping into a lot of folks that don't quite understand how to interpret a lot of the API specifications or PIP, ASME code. So
right.
a lot of the interpretations that get put in front of us, we got to scratch our head a little bit going, all right, how do we navigate this properly with our client to show them exactly how they should be looking at that situation? And that's
And
been a
that's
little bit of a
great. I
challenge.
think that's the sign of a great fabricator who wants a relationship with their client, with their customer. And I've learned an awful lot from folks like you and different fabrication organizations over the years, and it's because of those kinds of interactions. We might give them a drawing, and they'll come back and say, did you think about this? Or classic example I had was we had a column that required had to be cleaned out. Very cumbersome clean out procedure. Had to get way up on top near the roof, and then pull stuff out of the column, and it was all just very bad physical access kind of situation. And we sent the drawing to the fabricator. Unfortunately, it wasn't Ward, but um,
Why'd you do
we
that, Ed?
we sent the drawing to the fabricator, and I guess I happened to mention this challenge, and the design engineer came back with, well, what about a flat head? And I was like, what a great idea! I
Yeah,
never
yeah,
thought of it.
genius. Right.
So now what we did is with this whole problem overhead, we just loosened the bolts and we just turned this thing out of the way.
All right.
Full access. We got all the space between the top of the vessel and the roof. Whole problem went away just because of a little design comment and exchange back and forth. So
Yeah. Well, and that's what's great when you have a partnership like that because
exactly
we live it every day. I mean,
right.
we're building, designing. It's our life. I mean,
Yep.
we understand the specifications and how to fabricate things, and it's great to be able to coordinate and have that collaboration and a partnership like that. So that's fantastic.
Indeed.
Yeah.
Indeed.
Well,
I
let's
value
let's
those.
let's switch gears a little bit to uh, shop fabrication inspections, shop audits. So, from your experience, what would you say are the must-have inspection hold points during fabrication? The ones that you can't compromise on, no matter what the schedule pressure is.
Hmm. And that's always a discussion on the owner, user, customer side. Um, how much money do you have for inspection? I had those discussions all the time. When do you want me to go? Um, I know when I think I should go. What are you willing to pay for? How much does a project have for inspection, I should say? Um, and to me, I mean, let me back up. I don't know how to weld. I'm not even sure I could turn on a welding machine. I don't know how to spray a coating. I don't know, but I come in as the inspector, and suddenly I'm the guy that says, "Look, Jim, I couldn't put two pieces of metal together if I tried, but it's my job. It's your job to put them together, and it's my job to see if that's acceptable to me. So even though I can't do it, I gotta,
Right. You know what the end result needs to be.
yeah,
Yeah.
and I gotta say yes, it's good, or no, it's not, and this is why, or what have you. So that is even deeper relationship with the fabricator. I want Jim to do a good job for me.
Right.
So I'm gonna befriend Jim and say, hey, are you my guy on this job? All righty, man. Let's go to it. And if I come back on a future inspection, I'm like, hey Jim, how's it going? Everything going okay? He's like, yeah, job's going well. Great. Super. Um, here's here's a couple egg McMuffins for you and you and the crew, kind of thing.
Right. Hey,
And
we all love egg McMuffins. I mean, that's a win. That's a win-win.
I've done pizza parties. I've done, you name it. So, um, and I also like to convey, tell them a little bit about what they're doing. And it sounds like you do too, because you were mentioning at the cocktail party, you're telling people that, oh, we're doing a vessel to make a detergent or something like that,
Right.
right?
Yep.
You're doing something that they can relate to. Um, these guys, women, men, are tradespeople, are making stuff all the time.
Oh, yeah.
Do they know where it's going? A lot of times, maybe not. So I'm going to say, look, the reason this is important is because we're going to be running this whatever solid through here, or this product, and it's got to be smooth, or this weld's got, or it's going to be really corrosive. So we got to make sure that these welds are just the way we need them to be, and that kind of thing.
Yeah,
So
and that's great that you do that, because we try to do our best to relate all of our folks of, okay, guys, this unit, this pressure vessel, this heat exchanger, it's going into this process,
right,
so that they can visualize how they're going to use that product
yep,
in their own lives, to where, man, I need to make sure I put my 100% into this,
yeah.
because I'm going to be using the products from this. I remember a great story a number of years ago. One of our fitters got diagnosed with diabetes, and we were doing a large project for a company, and we were part of making diabetes, the
Oh wow,
injectable kind.
insulin. Yep,
Yeah, insulin. And so he was super fired up to hear that,
I'll bet.
because he was in his first year of learning this, and then to realize, man, for the next 4 or 5 months, I'm actually working on
Right,
units that are going to help save my life. And so we love sharing that with all of
that's
our
great.
teammates, because
Right.
it brings value to their life, and
Hmm.
I feel like that pride goes into their work, because they want it to be the best that it can be.
And you're touching on something important too, because to get back to your question about what am I looking for when I walk into the shop, you start to generate these relationships, and you can very quickly tell if people enjoy working there, if they're proud of what they do, how they carry themselves. You know, okay, I'm not somebody they recognize, so you get the unfamiliarity kind of glance, but do you get the heck are you doing here? Poking around my shop kind of look. That's not as welcoming a look.
So
Um,
so is that one of the first things you're looking? So when you come into a shop for the first time, you're doing an audit,
yep.
first inspection. What's that first thing that you're looking for? That physical or behavioral sign that kind of tells you whether this is a solid shop or there's something a little amiss.
It's dirty work, but cleanliness is a big thing. I mean, you know, and maybe not being. I'm not saying that you can't have a pile of grit in the corner or something like that, but I mean, to orderly, um, clean, tidy, organized, those kinds of things come across very quickly. I think the body language of shop personnel is, as I was saying, is another clear indication. You know, most fabricators, all the good ones I know, yourselves included, they don't mind being X-rayed. They want to be X-rayed. They want to show how good their welds are, not the fact that we barely passed or we're hiding something or anything like that. So and it's those kinds of things I think come across very quickly.
All right, Ed, now that we're talking about inspection hold points, let's talk about the exact hold points that you feel are the most important on a heat exchanger, pressure vessel, API tank.
Mhm. Good question. So project engineers, in my experience, they want you to say, oh, you gotta, their checklist says hydro. And I'm like, the AI's out, authorized inspector, the AI is gonna look at the hydro and sign. He has to sign it. She has to sign off on it. And quite honestly, if I see something we don't like or that needs to be addressed after hydro, it becomes an R stamp. Let's do it before hydro. Let's do it before hydro. If I look at it before hydro, I can see the inside of the vessel, for one. It's not full of water. make sure everything's good, make sure baffles are where we want them, coil's okay, whatever. Um, so I tended to for vessel inspection, I wanted to be there leading up to it. If I could, if they agreed to it, I'd also like to come in mid job and say, okay, you got cans made, you got heads laid out, you got all your materials, everything's good to go, because that tells me that the schedule's going to be met. Show me all the flanges, show me all the hardware. Let me see the holes in the heads. We're good to go. All the materials on site. So now it's all on you, the fabricator, to meet the schedule. You've got everything you need.
Yeah.
Um,
And I agree with you on the ASME code hydro part, because we see it all the time. That's the one inspection they'll do. And I'll kind of push back a little bit and say, all right, there's a lot of eyes on this at hydro. You got the AI, you've got us, and I can tell you right now, we're not going to ship a vessel that's leaking. I can tell you that right now. So if you've only got limited funds and can make only one visit, move that up. Just like you said, you want to be there before the vessel's done, and you're going to cause an R stamp. So I agree with you 100% on that one.
And it's worth. I had one situation. You reminded me something you said reminded me of it, where I was there for I think it was a smaller vessel. So I looked at it, and then the next day I witnessed the hydro, and boy, thank heavens I did, because I took a picture of the tank under hydro, and it was a kind of an oversized heat exchanger, and it was going down to Brazil, and it had the heads were quite large. It was about a 4 or 5 foot diameter vessel, so the heads were pretty heavy. They had lugs on the heads, and I'm looking at it going, they're gonna pick this thing up by the head lugs and not the vessel lugs. So I painted them yellow. I did everything. I wrote it on my inspection release form. I did everything I could. I sent them an email. I called them. I did everything I could. About a month later, they call me up and they say, we can't get the top head to seal. It's leaking. And I'm like, you lifted it by the head flange, didn't you? By the head lug, didn't you? No, we didn't. No, we didn't. I said, well, I got a picture of it holding pressure at the hydro. And sure enough, they pulled it by the darn head lug, and they deflected the flange, believe it or not. Which I thought they might. That's why we had these giant, vessel lugs, lifting lugs. But on heat exchangers, and I didn't learn this early. I learned this from hanging out, building heat exchangers, talking to people like you over the years. And it suddenly dawned on me, it's like, you know what? Bundle insertion is a really important step. For one, hopefully, I'm never going to see the outside of those tubes again, right?
Right. That's the goal. Right.
And secondly, just watching the bundle, the process of inserting the bundle, if it goes smoothly, that tells you an awful lot about the rest of the fabrication.
100%.
Right? Things are true. Things are, the shell isn't oval, right? The shell's actually round.
You don't have nozzles.
The measurements are fit, right?
Right.
Yes.
Yeah.
Tolerances are met. There's a whole bunch of things you learn without actually having to measure. But just the fact that happened easily says, okay, we're off to a really good, this is a really good step in the process here, and we're on our way to getting a really good vessel.
Yeah, and I agree with you. I tell clients, bundle insertion is the single most important inspection point on a heat exchanger, hands down, because you're going to get to inspect the inside of the unit. You get to see the nozzle welds on the ID. You get to ensure that bundle goes in.
Count tubes.
Right. You get to see the tube, because if you ever need to retube it and pull that bundle out, you want to know that you can get it out.
Right.
Because we've heard so many stories of, a 2 foot, 3 foot diameter unit. And if they're having to use a forklift to push that bundle in, that is bad news, because basically that means nozzles are sunk in, they're bending baffles, they could be crimping tubes. So bundle insertion is the single most important inspection point on a heat exchanger. I agree
Like I said,
100%.
and like I said, it's thanks to seeing fabrication and seeing other people's fabrication when I'm there looking at mine and things
Yeah.
like that, that I only came to realize that mid-career.
Yeah. That's a great point. Any other inspection points? Or those are the hot ones?
Those are the
I know
two biggies.
yeah,
Yeah. Those are the
perfect.
two biggies I think that make that generate the most value. Because I mean, if you're, and we've had jobs where you have a local inspector and they're coming in every week or something like that. But again, so is the AI.
Yeah.
So, I mean, I'll
You got
look
a
at
lot of
all that
eyes on it.
stuff. So, and I do the traveler, you're going to have a hell of a lot more hold points than I will. And you should, right? Your quality guy is going to say, no, we don't go any farther until we see this or whatever. I can say, let's make bundle insertion a hold point. Give me some notice. I'll be there. But that doesn't mean I'm not going to look at all the NCRs and the
Oh, it gives you an
X-rays.
opportunity to look at everything
And I'm not a weld
at a good
inspector.
time.
I'm
Yeah.
not a CWI, but I'm still going to look at the X-rays because I've found over the years I can see it. I can see a lot about, there's a big difference. The acceptance criteria for ASME code is pretty darn lenient.
Yeah.
Right. If you're down there, if you're down around those levels getting by, I'm not sure I want you fabricating my vessels, And I've had some where we use shops over and over again. We had one for furnace tubes. And there came a time where I started seeing some defects that I never used to see. They were always beautifully clean welds. And I said to the guy, I'm like, what's going on? I said, something changed? He's like, yeah, we had, we're trying to break in a new guy and he's learning, and it passed. I couldn't say anything about it. I'm like, well, keep working on him. He's getting there, but it's not, I'm seeing a clear difference in the quality. So
What's the first piece of documentation that you go to in a shop audit or an inspection that really kind of speaks to you that this group has their ducks in a row?
um, mine is probably a non-conformance program. I want to see the quality program. I want to see their sense of quality and safety. But to me, non-conformance reporting system is a big one because if I go into a shop and they say, "What do you mean non-conformance?" We don't have any. That's I'm gonna probably turn around and walk out.
Yeah. Because mistakes happen.
Because
Mistakes happen all the time.
and it's a good shops use it as a learning tool. Why did we not get the MTR? Why did we use the wrong weld rod? I mean, NCRs aren't necessarily huge. It can be missing documentation. It doesn't have to be, oh, we put the nozzle on the bottom instead of the top. Those
Right.
are that's unlikely. Those are
Yeah.
unlikely NCRs, and that's why I think there's a lot to be understood and learned from with that kind of a program.
Yeah. We've got a very comprehensive NCR program.
I know you do. Yep.
It's been an interesting journey for us. When we first rolled it out, just hearing the word NCR brought on such a negative connotation with folks
Mhm.
that folks didn't want to write it. And we kept preaching to everyone, listen, guys, finding NCRs and finding the issues and mistakes before it leaves our facility means that our quality control program works.
Exactly.
And it took a while to kind of get that mindset in everyone in every position. One of the big things that we ended up doing was we changed it from an NCR program to a job conformance report. So
Okay.
we took that negative NCR word out of it. We
Mhm.
added things like customer changes, value engineering to this JCR form. And so now it's just a job conformance report. So
Right.
when it hits the shop floor and it's released for fabrication, anything that happens after that, any minor change, whether it's a design change, we missed a dimension, MTRs don't show up for certain materials, we don't have the proper markings,
Mhm.
to, hey, we put the nozzle in the wrong location. Each one of those are a JCR.
Yeah.
And, we'll have anywhere from 5 to 10 JCRs on any given project because people make mistakes. They're
Mhm.
little mistakes, but
Right.
we're catching the little ones so that we can prevent a big one from happening. So it's been huge. It's been transformative for us as a company, and it's really allowed us to up our game and have a quality control system that really works.
Yeah, for
'Cause the
sure.
worst thing in the world is it gets to your site and you guys find a problem.
Right.
I mean,
Right.
that's everyone's nightmare.
Yep. And then, it circles back around to inspections also. Um, I'll measure everything I can, because for the same reason, if I've inspected it, I don't want them to go out there and place it and have the bolts not line up in the holes in the feet, you know? um, but the whole NCR program is very similar to a safety program, right? Monitor and report a near miss. Don't wait for somebody to get hurt. Just say somebody, hey, wait a minute, look what just happened. That could have hurt somebody. And let's do something to make that situation go away. So it's a whole culture mentality kind of thing, that if you can learn from things, and do so, it'll make you better.
Oh yeah. Safety is a big thing. And you touched on that, and it's a great topic. Bob Besh, he's
Mhm.
been running our shops for forever.
Yep.
And Bob preaches every time we talk about safety is when a guy comes over and points out, hey, maybe you should do it this way. It might be a little safer. The first words out of your mouth better be thank you,
Right.
because he's looking out for you. He's looking
Yep.
out for your family. And you don't need to look at it and go, I got this. I know more than
Yep.
you. You need to say thank you, step back and really think about the situation, because we're looking out for each other and we have to look out for each other.
Indeed.
A safety incident is no good for anybody.
I do the same thing on my inspections. If I'm,
Yeah.
getting lowered down a column, or climbing into something and I have a whole watch, I introduce myself to them. It's like, I'm Ed. I'm
Right.
Mike.
Yeah.
Okay, Mike.
Right.
Anybody looking after my well-being is a friend of mine. So you're my friend
Exactly.
today.
That's the
You
truth.
know?
Yeah. It's got to be that way.
Yep.
So let's circle back. When you're coming to audit shops, what is one of the common reasons good shops struggle? What do you see consistently that would help them be audit ready year round?
I don't know if I see one thing that makes good shops struggle. Because good shops have a culture and a confidence that um, kind of serves to serves to provide. You know, I'm not looking for my audit is not looking for problems necessarily. I just want to make sure that you have competencies and those kinds in these certain areas. Um, I mean, are your cranes heavy enough for what you're trying to do? That's not going to make a shop uncomfortable. Um, so I don't know. I'm not time out on this one. It's not
Yeah.
um,
What
kind of stumbling through this one
well, so
as to why
what
a
advice would
good
you
shop
give?
would get nervous.
Yeah.
Hmm?
What I guess let me spin that a little bit. So what advice would you give to fabricators or just any manufacturer in general to make their audits smoother and more effective? Is there a couple
Yeah,
things
I
there?
mean, it's not a first off, it's not a quiz. It's not an audit is a review to make sure that the shop can provide what I'm going to need for my vessels or my products, whatever. Um, and it's not a dig at the fabricator. So the fabricator should be honest, and evaluate, and it's it's not a sales function. It's not a marketing function. It's an audit. So uh, I think sometimes shops think of it as, oh my gosh, it's whether or not they're going to use me or not. Well, I guess in a way, yes, but really what I'm trying to do is make sure that you can do what I need you to do.
Right.
And
So
don't be scared of
you don't need the sales guys sitting in a conference room trying to pitch you on the job. You need the
it.
engineering manager, quality control manager
Right.
showing, hey, you say you're going to do X, Y, Z. Let me see that your program supports that.
Yep. Exactly.
Perfect. Perfect. So let's talk about MTI. I don't think we really defined that earlier, but that's the Materials Technology Institute. We're
Indeed.
members. You've been a member for a long time. You've been tied with them for, I guess, 3+ decades,
Yeah.
and you were named MTI Fellow, and you're now the Associate Director.
One of them. Yep.
Yep, one of the Associate Directors. So
Yep.
tell me how that community has kind of helped shaped you into who you are and how that enhanced you as a reliability and materials expert.
Yeah, it's been a great ride and still riding that wave. I think it's a fantastic organization. I mean, for those that don't know, MTI is it's an industrial consortia where members pitch in dues, and we try and solve non-proprietary challenges that member companies have. Excuse me. So we create project teams on around some idea. I think you guys are involved in one on half pipe coil repair, um, and so it's an issue that the challenge would be something that everybody experiences, but instead of solving it 62 times, we get together and do a project that covers the basics, and then we can then each member company can pull out that material and apply it to their specific operations.
Yeah, so
And
it gives you a good base then that you can then have a good project,
absolutely,
good base, and then you can take it in the direction your company needs it to
we've
go.
done a lot on inspection practices and things like that. Well, that's going to be unique to everybody. So exactly. So you take the project output and then go apply it to the specifics of your process. And it's a tremendous resource. There's going on 50 years worth of forum discussion, which is where somebody, John Ward just goes in there and posts a question about, hey, we're having trouble sourcing material X. Anybody know where it's made or who's got, whatever. I have a corrosion problem. Has anybody experienced a similar problem? Those kinds of things. And I always found it as a resource, tremendous resource, and getting to meet others like my peers in the industry, and of course the culmination of that is to have been elected a fellow. There's no higher honor than to be honored and recognized by your peers. There's just not. It's wonderful. Um, and the whole organization. I mean, it's one of efficiency. I mean, we talk about AI and all these kinds of things making us more efficient. Well, MTI does that too. I mean, it helped me solve problems so much more quickly that doing it alone would have taken me days, weeks. And I post a forum question, and within a couple of hours, I have valuable input. And they try and capture this with their value award. So they try and capture some of these examples, kinds of things. But I mean, in today's world, the pressure to make decisions quickly is mounting, but so are the ramifications of bad decisions. Okay, I
Oh,
mean,
yeah.
you
Yes.
know,
Well, yeah,
so
I'm always blown away. I'm on that forum email and some of the questions that come out and the suggestions and recommendations that come quickly. I
yeah,
mean, it's not like someone puts a question out there and it's days they're waiting. Within that same day, it's amazing how
right,
many folks just pour their knowledge into it for the common good of the industry.
exactly,
It's
yep.
phenomenal. Yeah, it is.
It's a wonderful climate. Mhm.
Yeah. So I know MTI, they always work on projects, and you've been involved in a lot of projects. Explain that process a little bit, how that works.
So yeah, I mean, somebody comes into the forum or to a meeting and says, we're having an issue with this chemistry. And you can't get too specific. If you get too
Right.
specific, like my company used to make sodium hydrosulfide. If I come in and say I have a problem with 45% sodium hydrosulfide at X temperature and whatever, I'm not going to get a lot of help.
Right.
There's not going
Too
to
too
be a lot of
specific.
traction.
Right. Yeah.
But it occurred to me that the paper industry might have an overlap. So instead of saying 45% Nash, I said, help me out with alkaline sulfur bearing chemistries. And I got a whole bunch of responses.
Yeah.
And
Yeah.
I could go then, and peruse through, and I was finding myself in tappy documents and stuff like that all over the place,
Yeah.
because I asked the right kind of a question. So you come into the organization with that kind of a general issue, and then other people join in and go, hey, yeah, we have a similar chemistry, or we have something that relates to that. We have some experience there. We've there's supplier members too. We have an alloy that would address that. We've made equipment
Yep.
in that industry, kind of thing. Uh, so then you get this collection of the project team, and from there you kind of create a project summary and get some ideas around who might be able to help you with this deliverable.
Yep.
Find a contractor, apply, go to the advisory council for a funding request, and if you get your funding, away you go.
Yeah. Because I love seeing folks get up, and I've seen you in the past get up and present your project and put it forth to the whole group and see if you can get approved for the funding request that you need.
Used to be harder than it is now, but that's a long story. We won't get into it.
They're getting a
The
little softer.
organization's changed a little bit over the years. So.
Okay. All right. You're a little bit more on the hot seat back in the day.
Yeah.
Gotcha. So now, what what project or initiative that you brought forth that you're most proud of that helped change the industry in your mind?
Been a lot of really good projects. You look back through the website and the projects the organization has done. The one that really struck me was one I actually did not come up with, but I took over from a guy that unfortunately left the organization, and that was the mechanical integrity of civil structures. Long overlooked, right? You can have a reactor sitting up there in the structure. You can inspect it every 10 years, or you can look at it outside every 5 years. You can do your UT on it. It can be in great shape. It's reliable. You know exactly what's going on with it, and all of a sudden it falls down.
Right. Because the structure was bad.
Because the structure was bad. And nobody was really, API 653, big, flat bottom tanks you see in the oil industry, stuff like that. There's a lot around the foundation and things like that. API 510, you kind of go out to the support lugs, and that's kind of where it is. Make sure that what it's sitting on is okay, but it doesn't really go any farther than that.
Right.
And this project kind of took you around, columns, pillars, I-beams,
Oh, you got so
stuff
much.
like that.
Yeah.
Your cooling tower drift or next to a chlorine plant or, whatever. We've had issues over the years where, stuff is just rotting out, and you need to pay attention to it, and you can't do it all at once. So, I took the MTI document, which was pretty voluminous. And I brought it down to a kind of a 2-page or 5-page document where I had, just priority 1, 2, 3, and 4. And that was it. And I just had a picture of each one and say, look, if it looks like this, put it on the list. We got to get after it.
Yeah.
If it looks like this, we want to watch it. And we would like to get after it, maybe next year, that kind of thing. And just do a little rating system. You can't walk into a plant and say, oh my gosh, you got to tear the whole place down and rebuild it because your structure's bad.
Right. No one's going to listen to that.
So, yeah.
Talking about structures, I'll never forget. This is probably about 15 years ago. We had a half pipe reactor that where the supports were, the coils were failing. Getting a lot of leaks and having some fatigue issues there. And they called us, and so I went up to inspect that unit. And when we were up there, we were walking to the unit, and all of a sudden, the whole building started shaking. And to the point where I went to look for a handrail. It was rocking, and the noise, and the hammering and all that stuff. And I looked at the my escort and I said, "Oh my gosh, what in the world was that?" He said, "Oh, well, they're starting up that reactor that you're coming to look at." And I said, "Well, I can tell you what's wrong right now." I mean, your startup, I mean, it shook the entire building
Wow. Yeah.
and the structure. So yeah, there's so much more than just the vessel itself.
Indeed.
So I love the fact that that was a great project for you.
Yeah.
Well, let's jump to the newbies coming in the world. Advice for
Mm.
new engineers, inspectors, maintenance folks. What would you tell them to look for? What advice would you share with them as they're just kind of jumping into maybe their first 5 years?
Yeah. My entry into the industry was facilitated by having a mentor. And that just, no company these days wants to pay two people to do one job. And that's exactly what was happening when I started. Is I would go along. I mean, okay, I'm the gopher. I'm the secondary inspector, that kind of thing. I helped, but it was basically two of us going where one of us could have. Um, so I mean, if you don't have a formal mentor program, then my advice would be to find somebody that you get along with, that knows what's going on, and attach at the hip,
Yeah, yeah.
and
Tap,
listen to
tap them
every
on the
story
shoulder
they
and say,
have.
I want to be a pro today."
Yep. Yep. Listen to every story they have, whether it's applicable or not. I can't tell you how many World War II stories I listened to over lunch with this guy, just to get that nugget of here's what stress corrosion looks like, kind of thing.
Yeah,
But yeah, it's that's the biggest challenge, I think. And there's a lot to any company. How does the company actually work? Half
right.
the time you come in brand new and you don't even know that. How do you file an expense report? But there's an awful lot to whatever you're doing, whether it's process engineering or welding or whatever it is. There's an awful lot you can learn. I mean, that's all the trades have apprenticeships, right?
Right.
Well, you'll go all the way up through, whether you're a plumber, an electrician, or welder. You got to make your grade
Yeah.
and work your way up. So
I
why
think,
shouldn't the same be true of an engineer?
yeah, no, I think that's great advice because I think everyone should have a mentor.
Yeah.
I know when I came into the business and, I took over the business at a fairly young age.
Hmm.
I had my dad to lean on, but when I look back on that, it would have been good for me to have someone that I really connected with early on just to bounce
Hmm.
ideas off of.
Right.
Because at the end of the day, everyone has been through what we've been through. It's just a different year. But
Yeah.
everyone goes through the same motions and learning process. So
We
I
say that
love
to our kids, don't we? I
Yep,
was 16 once. I
yep.
remember.
We were there. We were there. Yep.
Oh no, Dad, you don't understand.
Right. Right. Oh, but yeah, no, I think that's great advice. Everyone should reach out, find a mentor.
Yeah.
100%. So what are some of the most underrated skills would you say for an inspection or corrosion engineer today? Things that don't show up on the job description.
Um, I think the biggest to me would be interpersonal skills. You got to be able to get along with people, and the better you are at that, the more you will learn. I walk into a plant, I greet the project, I mean the plant manager, make sure that they know I'm on site and what I'm doing there. And then I almost as quickly as possible leave their office and go find somebody who actually knows what's going on. And that might be the operations manager, it might be the mechanical integrity engineer, but it also might be one of the operators, somebody in a control room, people like that. Talk to everybody, get along with everybody. I got to find out, in those cases, I was trying to solve a corrosion problem. I need to know what's going on. Well, we don't, the plant manager doesn't know. He just knows he has the problem. He knows the plant's down, but he doesn't know, maybe he knows the reactor has an issue or something like that, but he doesn't know why. The operator knows why. And that's what you got to find out. And I want to make sure that, so I mean, communication's a big thing. But I think as far to, for the overlooked issue, I think it's interpersonal skills.
Yeah. And I would agree with that because especially in the role that you were in, you're going to eventually have a difficult conversation
Yeah,
about what's going on, what needs to be done. And if you haven't created those relationships before that conversation is probably not going to go the way you want it to go.
that's right.
And
And
so,
if I come in like all high and mighty, I'm
yeah,
here,
beating
I'm
your chest,
Superman,
I'm Big
here to
Ed. Yep.
here to solve all your problems. I'm not going to learn a thing, and they're going to make a fool out of me.
Yeah.
So
No, that's great advice. Great advice.
very true.
So, what books, standards, resources have most influenced you about plant integrity and maintenance that you could share with others?
I mean, I think the API inspection codes and supporting documentation are terrific documents. I think the petroleum industry has done the entire chemical process industry a world of good, generating those documents. And I think the whole I encourage people to get some of the certifications. You don't have to get them all. I kind of went overboard. I think the process of really understanding the codes and the inspection practices made me a better inspector. More than just getting the certification, you got to kind of know what you're doing and why and what you're looking for and those kinds of things. And I think those documents really help me. Reference materials these days, um, MTI has a new AI function in their behind the firewall for their library, which I think is a terrific tool. Magnificent. I mean, because I'm the first to admit I like hard copy books, but I'm not going to read them cover to cover, and I'm not going to, I have a couple I go to that for reference and things like that. But that AI tool is fantastic because it'll tell me go to MS3.
Right. It'll
That's
take you
where
where you need to go.
it'll show me exactly
Yeah.
where I need to go, which is a
Yeah.
common problem. Don't take AI as the answer. Take AI as the tool to get you closer to the reference that tells you what you need to know.
That's great advice. Now, as far as the certification, is API 510? Is that what be the first one to
510's a
go
great
after?
one. 510's I was about to say it was the most useful, but there's a lot more piping in the world than there are pressure vessels. So maybe
Mhm.
570 is actually,
Okay.
but for vessel inspection, there's a lot more concentration on vessel inspection. So I think 510 and 570 to me are the two real go-to documents. I
Okay.
did a lot of source inspection, as you know, that's how we met.
Yep.
Um, doing shop inspections and shop audits and those kinds of things. So the source inspector certification gave me a little bit. I'd been doing it for years before that thing even existed.
Yeah.
But when it came out, I kind of grabbed it. I said, "Well, it gives validity to what I'm doing at these inspection." So
Very cool. Very cool. Well,
yeah.
hey, as we close this out, it's been a lot of fun. I want you to look back on your career and what's the failure near miss that taught you the most?
Oh wow. Failure near miss that caught me the most. I would actually say it was one that was very recent, like within the last couple of years.
Okay.
Was a firewater tank rupture,
Hmm.
and it taught me the power of water.
Yes.
500,000 gallon tank, eggshelled wide open.
Oh,
Um, it taught me the um, intricacies of. It was a plant that had two owners present on the same site.
so it's
So there were
JV,
those
joint
kinds of
venture?
issues. No, it was, you know how you you know how Air Products, they put their own
Yeah,
little plant inside
that's
another
right.
plant.
Yep.
It was that kind of a situation where one plant was operating on another plant site. So yeah, and there was some indication that the tank was degrading. That was kind of ignored. So pay attention to stuff you see.
Yeah. Yeah, it's
And
spooky. Yeah, water
Yeah,
water is a
and that's I'm sorry
powerful
if I
force.
interrupted you, but
No, no.
that's one of the reasons, that API and mechanical integrity programs emphasize walkarounds.
Yeah,
Now, you're supposed to do a walkaround, like, every week, every day. Some people do it every day. Walk your process area, and look for something that doesn't look right. If something doesn't look right,
ask
point it out, and
yeah,
let's get
uh,
somebody to take a closer look at it.
yeah, ask some questions for
At least
sure.
explain it. Right, yeah.
Yeah, yeah. So if you could snap your fingers and change one thing about the industry, about how they approach safety, reliability, materials, what would it be?
Um, hmm, um, have a designated mechanical integrity or reliability engineer at your site, fund them and empower them. We had a couple of sites that did, and one site in particular I can think of where that person could shut down the plan or delay a startup kind of thing. Um, Not without being asked a lot of questions. You gotta justify it. I mean, plant manager wants to fire up, and it's like, well, why not? What's so specific? Of what have you seen? What's with this vessel that gives you cause, pause for concern? And but that kind of a function, too much nowadays. We're throwing it on the maintenance department. You got a maintenance engineer, and okay, you got to do reliability also. You got to do the mechanical integrity program, and it's just loading up more and more and more and more, and it's not working. It's a whole person's function, if not more. Larger sites, it's going to be a whole department, and I think that appreciation is what I would try and change.
Yeah, no, and I hear that a lot from
Hmm.
individuals around that, uh, they just don't have that stop work authority at some sites,
Yeah,
which is unfortunate. We tell our QC managers, hey, you have full authority. If
right.
something's not right, I mean, you stop it. Because I think the tendency sometimes is to lean towards operations, production.
Yep.
I mean, that's the money maker. We're making money, we're making money. And sometimes you just got to stop
Hmm.
and do it the right way. So I appreciate you sharing that because that's huge.
Great.
Yeah. Yeah. So what's next for you? What problems in reliability and corrosion are you still excited to tackle?
No, whatever comes in the door, it's fun. And that's the whole career, the whole industry, the whole area of materials technology is just vibrant, and things are advancing, and um, new welding techniques,
Yeah.
all kinds of things are changing. We're getting into robotics and
Oh, yeah.
orbitals, and
That's changing
tandem
quickly.
welding,
Yeah.
and stuff like that. It's
Yeah. The
all
world of
kinds
the
of
world of
fun.
welding is changing rapidly, which is
Yeah.
exciting. I mean,
Yep.
AI is getting involved. I mean, I'm excited to see what the next 5, 10 years holds for us
Yeah.
from a welding perspective. So that'd be great. Well, listen,
Well,
Ed,
we
this
need
has
more of
been
them. We
yes,
need more of them.
yes,
This whole situation, and it's getting a little bit more publicity now.
yep.
That not everybody has to have a 4-year engineering degree to be successful. My lights go out, I'm still calling an electrician. I'm not,
Right. Well,
so
I feel we're having a renaissance of the trades right now. I mean,
it's
we're
good.
seeing
I'm
it,
glad to hear that, because I
we're
thought it was such
feeling
a
it.
good.
Yeah, yeah, and we're doing our part. I mean, we're connecting with high
I
schools,
see that.
colleges.
Yes.
Uh,
Good for you. Good
I
for
think
you. Yep.
the reality has set in that the cost of tuition for college is so high, and there's so many kids that are graduating right now from college, and they can't find a job.
Well, and you know that firsthand because you have to
Oh
write
yeah,
these checks to LSU.
yes, I
I mean,
know.
your hand must have been shaking. I wrote my checks to Ohio State. I'm just saying. You had to write your checks to LSU.
I know. That's the crazy part. I'm over here roll tide, and I got to say, go
Yeah,
Tigers,
yeah, yeah.
go Tigers.
All your money went to Louisiana. They're sitting down there in Baton Rouge saying, "Hey, it's John's money."
Right. Oh, trust me, I hear about that a lot from a lot of different people. They enjoy the fact that I've got to send some dollars down to Baton Rouge.
Yep, yep.
Yep. And go Tigers has kind of rolled off my tongue a little bit
Right.
smoother than it used to.
Taux, right? Yep.
You got it. And Tigers, Tigahs. It still doesn't want to come out easily for me.
That's right.
It's
Yeah.
still a struggle. It's still a struggle.
Good
Oh
stuff.
man, good stuff. Well, listen, Ed, this was gold, and I really appreciate you providing the incredible insight on reliability and inspections. So good as always to talk with you, and I
Thanks, John.
thoroughly enjoyed our conversation.
Say hi to the gang at Ward.
I will. And look forward to seeing you again soon.
Okay. Take good
All
care.
right. Have a good one. Thanks, Ed. Thanks for joining us on Forged in Focus. If there's one takeaway from this conversation, it's that reliability isn't something you inspect into existence at the end. It's built in, step by step, during the fabrication. The best shops don't fear audits. They don't scramble for paperwork. They know where the risk is. They control it early, and they catch problems when they're still cheap and fixable. Ed's stories today are a reminder that most failures are predictable and most of them are preventable. If you're willing to slow down at the right moments and ask the hard questions, things can be predicted. Ed, thanks for bringing the hard-earned lessons and real-world perspective. And to everyone listening, if this episode made you rethink when to inspect, how to audit, and what you tolerate in fabrication, then it did its job. Let's keep the momentum going. Until next time, I'm Jon Ward. Stay strong, stay focused, and keep forging ahead.